Today's lesson covers 6-4, which is rational exponents. So keep in mind that the first five letters, first five letters of rational spell ratio. So our exponents are going to be a ratio, or what you know of as fractions. Okay? And most importantly, you need to know what the definition of how we define those rational exponents. And when you have a rational exponent, this says a to the 1 over n equals the nth root of a. So that's one part of it. They also expand it if you have an exponent. Okay, a to the m over n equals the nth root of a to the m, or the nth root of a raised to the m. Okay, so look at this example. It says draw a line from each expression in column A to its exponent form in column B. And one of the things, when you're going back and forth, that might help you remember is that m is on top and it is the exponent, so it will stay the exponent. I actually remember this little diagram, and whatever is on the bottom is what becomes my index. So when I'm looking at this, the one that's a cube, that's my index, and that has to go on the bottom. So I'm going to have a 3 on the bottom, which means that this one is going to go here, and that's got an index of a 4, and the 4 is going to go on the bottom. So that's what's going to go there. Okay? We're going to do some more examples. If you want to pause, think about them first, or continue watching. So the simplified form of this next expression, this is like asking, okay, the square root, okay, that is the index, so that's the square root of 64 to the first power, or the square root of 64, which is 8. Okay, then we have 11 to the 1 half, don't lose it on me, 11 to the 1 half times 11 to the 1 half. Okay, you can think of it as the square root of 11 times the square root of 11, and we've talked about that a lot, and I know you all know that that is equal to 11. All right, in this last one, 3 to the 1 half times 12 to the 1 half to the 1 half is the square root and the square root. Okay, and we've talked about that. You can multiply them out, or you can do 3 times 3 times 4. We've talked about breaking it up first. That's a perfect square. Square root of 4 is 2, so my answer is 6. And yes, you could just multiply them out, but it's a habit because we try to keep our numbers small. Okay, so look at number 2. What are the expressions? So we kind of got two problems here, 2a and 2b. What are the expressions w to the negative 5/8 and w to the 0.2 in radical form? So I'm going to do two of these on one side. I'm just going to divide this in half real quick here. Yeah, good thing it straightens it out. Okay, so w to the negative 5/8. We have w to the negative 5/8. Okay. I hope y'all remember that negative is the same thing as putting 1 over w to the 5/8. Okay. Let me keep going down here. Get some more room. So that is 1 over, okay, the bottom number is the index, so that's the 8th root of w to the 5th. Well, we've talked about this a lot. If I have an 8 out here and I have 5 inside, how many more do I need? Okay, and we've talked about that that is still the 8th root, but I need 3 more w's, and I do the same thing on the top and the bottom. So we circle these because now I have 8 w's, which means I have just a w on the bottom. And then on top, I have the cube root, the 8th root of w to the 3rd. And there it is, simplified. Okay, what about the one that said w to the 0.2? So 0.2, you've got to think about that as a fraction. That is 2/10, which reduces to 1/5. And so that is just going to be the 5th root of w to the 1st, and we don't have to write the 1st. Okay, what are these expressions in exponential form? So the first ones we were putting them into radical form. Radical form is when we have that symbol. Now we're trying to get rid of the symbol. So if I have the fourth root of x to the third, then remember the exponent it stays on top and the index is what goes on the bottom. So that becomes x to the 3/4. And then I have the fifth root of y to the fourth, okay, which, however you wish to think about it, that is y to the 1/5 to the fourth. When you raise a power to a power, you multiply them, so that's 4/5. So it is y to the 4/5. But this does bring up something, okay? When you have your exponents, okay, and on top we had, what did that thing say up top? Let's look at that real quick. It had m over n. That's what it had. So it was um, the mth root of a to the n, okay, is the same thing as the mth root of a raised to the n is the same thing as a raised to the n over m. M is still the index in each case, but sometimes this is the preferred one to use because you're simplifying the radical before you raise it to a power. Because if you're raising it to a power first and then taking the root, then you're going to end up with larger numbers. So just know that that's easier if you will take the root of a number before you raise it to a power. Okay? All right, so the next page, properties of our rational exponents. Same thing we did with exponents before, y'all. Okay? So when you multiply exponents with the same base, you add them. Okay? When you raise the power to a power, like I just said, you multiply them. Um, when you have, this is here's the one dividing that we've kind of talked about already, okay? When you have, when you're dividing, you subtract the exponents, okay? This kind of thing. When you're raising a product to a power, okay, there's no plus or minus inside these parentheses. You cannot do it with plus or minus, okay? But if there's no plus or minus, then that exponent distributes to everything in your parentheses, whether that is a product or a quotient. And then, of course, we just talked about this. If you have negative, then you put it in the bottom and make it positive. If it's negative in the bottom, you put it in the top and make it positive. But you'll see that as we go along. So g to the third times g to the fourth is g to the 3 plus 4, which is g to the 7th. Okay. H to the third to the fourth is h to the 3 times 4, which is going to be h to the 12th. 5y quantity squared, okay, that's a product, so that I have to put that 2 to both terms. They didn't have me simplify it further, but I would prefer that you give that as 25y squared. Okay. 2 to the negative 6 is 1 over 2 to the 6. So negative on top, I put it on bottom and make it positive, and 2 to the 6th, of course, is 64, so that's 1 over 64. Then we have d to the 8th, d to the 3rd. They subtract. 8 minus 3 is 5. But we've talked about this. When you look at something, where do you have more? I have more on the top. How many more? I have 5. You're still subtracting. Okay? And this last one, again, is a quotient raised to a power. Again, no plus or minus in there, so that exponent goes to everything inside, and that, of course, gives us 9 over 16. So, practice those again down here. What is each product or quotient in simplest form? So, 3 to the, this is the kind, y'all, before that you couldn't simplify it because they had different radicands. But if I write it as 3 to the 1/2 times 3 to the 1/4, then I add my exponents because I have the same base. And 1/2 plus 1/4 is 3/4. And so I'm going to put that back into the radical because that's what it came. So that's the fourth root of 3 to the third. And 3 to the third is 27. So that's what that equals. Might mess with your brain a little bit. Okay? But you practice. Okay, so this is giving me Let's go with, on the top is x to the 3 over 2, and on bottom is x to the 2 over 3. Okay, so this time it's probably better to remember that we subtract those two because they have the same base. So that equals, let's go make that x to the 3 halves minus 2 thirds. So 3 halves minus 2 thirds is equal to 5/6. So this becomes x to the 5/6. Then my original problem again came with the radical, so I'm going to give the answer in the radical. And that means that my final answer will be the 6th root, because that bottom number is my index. The top number is my power. And that's what your answer will be in simplest form. Okay, look at the next one. We have similar to the first one, so we're going to have 7 to the 1/2 times 7 to the 1/3. I add my exponents, so 1/2 plus 1/3 is 5/6, and that is equal to the 6th root of 7 to the 5th, and 7 to the 5th is 16,807, because I know y'all keep that number in your head. Okay, so now we have some that we're going to put in simplest form, but we're starting off with a rational exponent. Okay, so when you're doing these, we have 32 to the negative 3/5. Okay, so this is the one where the power I'm actually going to put on the outside because I want to simplify it first. I'm sorry, that's not the right number that goes there. Y'all weren't here to stop me. The 3 on top goes. And what does that negative do to it? Okay, again, that negative, put it in the bottom and make it positive. So my 3 is the exponent. My negative made me put this thing in the denominator, 32, and the 5 is my index. So as I'm looking at that, okay, that's 1 over, what's the 5th root of 32? That is 2. So 1 over 2 to the 3rd gives me an answer of 1/8. Okay, it's important that you understand these, y'all, because we're going to get into logs next, and they will be challenging if you don't get it down. So make sure you write down any questions you have. 16 to the 3/4, okay? It's positive, so I don't have to worry about putting it in the bottom. But I have a radical. This is my index, okay? And I want to take the root before I raise it to a power. So the 4th root of 16 is 2, and 2 to the 3rd, we just found out, is 8. So this answer is 8. Okay? Look at this next one, 9 to the negative 3.5. Well, negative 3.5, y'all, I hope you know if you multiply that by 2 is the same thing as negative 7/2. So that means this is going to be 1 over, because the negative is what's putting the negative exponent is what I put in the bottom and make it positive. So it is the square root of 9, that's my index, raised to the 7th power. Square root of 9 is 3. So we have 1 over 3 to the 7th. And I know you keep 3 to the 7th in your head. So, real quickly, that's 2187. 1 over 2187. Okay? And the last two problems that we have, what is each expression in simplest form? Okay? If I have a negative 1/3 and I have a 15th, keep in mind, I don't know which one you think is easier, but you can do this more than one way. So whichever one comes to your mind is the one that you need to do. Okay? Um, I don't really like to do with negative exponents, so I'm actually going to go ahead and put it in the bottom. That makes my negative positive. And the third means I'm taking the cube root of this thing. So this is the cube root of 8x to the 15th. And so I have 1 over 8 is a perfect cube. We circle that. 15 is going to be a perfect cube, so they're both going to come out. I don't have to worry about simplifying that radical, rationalizing it, I mean. Cube root of 8 is 2. Cube root 3 goes into 15 5 times. So we are good. 1 over 2x to the 5th. Okay? Last problem. I have 9x to the 3 halves. Okay, so I'm going to, well, we can go ahead and do this. Let's go ahead and write 9 as 3 squared because I'm going to take 3 halves to this and I'm going to take, well, let's do this. We'll do this first. We're going to rewrite it. Okay, I'm going to rewrite it inside the exponent, all with rational because it'll be easier. So 3 squared x and y to the 1/4 because that's the fourth root of y, and I'm raising it to the 3 halves. So when I do that, I have to take the 3 halves and I have to put it with each exponent. Okay, so that's going to give me, it's going to give me 3 to the 2 times 3 halves, because remember when we raise a power to a power, we multiply them. So I'll go ahead and write that step. So that's 3 squared times 3 halves, and then x to the first times 3 halves, and then y to the 1/4 times 3 halves, because it has to go to everything inside of there. So when I do that, okay, my 2's cancel. That leaves me with 3 to the third, okay, x to the 3 halves, and y to the 3/8. Now, you might ask, what do you do now? Now, our variables aren't going to, uh, we're actually going to put them all with the same denominator because I started off with a radical. I'm supposed to end up with a radical. So that 3/12, if you think of 3 halves, excuse me, I just don't need the answer. If I have 3 halves and I need to make it eighths, I need to figure out how to make it 8 on the bottom. Then I hope you realize that means I multiply the top and bottom by 4. So that gives me 12/8. Gotta hurry up, here's the bell. So this is the same thing as 12/8. And so that gives me 3 to the third is 27 times the 8th root of x to the 12th and y to the third. Now, do you need to go further? You can, because you can't leave an exponent larger than that index. So we need to go one step further. How many times does 8 go into 12? It goes one time. And then how many do I have left over? I have 4 left over, and I still have y cubed. So both of my exponents are less than my index, so I know that I have simplified that as far as possible, and I have combined everything under the radical that can be. Okay, so that sums up rational exponents. If you have any questions, I hope you wrote them down or come see me in AO.